This time around, we are going to take convolution of uh, discrete time signals. Okay, and it's more or less you doing the numerical convolution. Okay, so let's take this question. You have been given two signals. You have been given x of n and h of n, right? Now, to do this, it's you have to just write out a table. Okay, so you first can write out a table, right? A table showing labeling the x of n and the h of n. So you realize that x of n runs from 0 to 04624 642, and h of n runs from 3 minus 1 to positive 1. Now note this: when the question is given to you and they don't indicate where your 0 point starts from, okay, then you can assume your 0 point as the first one. Okay, when they give it to you and they indicate where your 0 point starts from, then you can't make that assumption. Okay, so we'll try solving using both ways. So let's say this question, the 0 point, we are using the assumption and the 0 point is the first one. Okay, now the very radical method or the step-by-step procedure you have to use is this. So you first write your x of n's down, right, in a tabular manner, and that's what you see, right? Then you can write your h of n's as well. Now you realize that once you do that, the next process is to calculate the convolution. And if you remember, the convolution is given by this formula, right? H of k multiplying what? X of n minus k. So what it means is that at every point in time, the nth y, it's equal to the kth h multiplying the shifted x. Yes, confusing when you see it in English, but let's see it in maths. The procedure is simple. Okay, so first one, you first pick h of 0, because remember, k will run from 0 to the last number. Okay, yes, and h will also run from y will also run from 0 to the last number. Okay, so you first pick the h of 0, right? Now you realize that h of 0 is the first one, right? Then you also have to multiply it by all of x, right? So you realize that here's what h of 0 times x of n, right? So you multiply it by all of the x. So when you multiply, um 3 times 2 is 6, 3 times 4 is 12, times 6 is 18. You can go on, you can do this. Then you come and take h of 1, right? And now this time you are not just going to multiply it by all of x of n, you are going to shift x of n by 1 to the right. Okay, that's the meaning of what n minus 1. It means go 1 to the right, right? Delay the signal. Okay, so when you do that, now h of 1 is what? Minus 1. Okay, so it will multiply it this way. 1 negative 1 times 2 will give you negative 2. Negative 1 times 4, do you realize it? So the first position will be 0. Okay, negative 1 times 6 will give you negative 6. Negative 6 times 4, and you continue. Then the next procedure, you have to what? Shift by 2. So you leave 2 spaces before you start it, right? By this time you're doing h of 2. H of 2 is 2. So 2 times 2 is 4. 2 times 4 is 8. Then 2 times 6 is 12. Okay, to the end. And you continue throughout the whole process till you reach the last h. Okay, now after you have done the tabular which you use for the multiplication, right, you just have to add them. So here 6 plus 0 plus 0 plus 0 is 6. 12 minus 2 plus 0 plus 0 is 10. And 18 plus minus 4 plus 4 is 18. Yes, you can add them. And that final answer will become what? The convolution, the numerical convolution, if you want. Okay. But in the heat of exams, this is not efficient. Okay. Because, I mean, you can't be doing shifting and multiplication all the time, right? But if you want to confirm your answer, you can use this. So what you do is that you realize there is a common rule that says that convolution in the time domain is equal to multiplication in the frequency domain, right? That's a rule. So I hope you remember that rule. So that's the rule you use, right? So let's quickly get to the board and do that one rather and see how fast we get. Um, and that's this way. So our x of n was this 24642. Our h of n was 3 minus 1 2 1. Okay, that's from the previous question. Now what we can do is let's find the z transform, and I hope now you can do that. So to the z transform, like this is the zeroth term, so starting here is 0, right? So the first one will be just 2, right? the Let me write it as a polynomial. Okay, so 2 plus the second one is what 4 by the second term, right? So 4z minus 1. The third term is, or let me put it in vertical format so that we don't. So the we have 2 plus 4z minus 1 plus 6z minus 2 plus 4z minus 3 plus 2z minus 4. Hope I'm right. And this one, if you transform it as a polynomial as well, it gives you something like 3 plus, oh no, the second term is negative, so it will be 3 minus z minus 1 plus 2z minus 2 plus z minus 3. Yeah, so I hope I'm right. Then what you are left with is that multiply them. Okay, yeah, so it's not a difficult thing. So what I will do is when you are doing it, okay, take time to keep the multiplication hierarchical. That's what I mean. So take the 3, right? Use it to multiply all of the top. So 3 times all of the top is 3 times 2 is 6 plus 3 times 4 is 12. So 12z minus 1 plus 3 times 6 is 18. So 18z minus 2 plus 3 times 4 is 12. So 12z minus 3 plus 3 times 2 is what? 6. So 6z minus 4. So we've done with the 3. Now take the minus z. Go through the same procedure. So start multiplying um, with the minus z. So realize that minus z times 2 give you minus 2z. Yes, so minus 2z minus 1 plus minus z times 4 will give me minus, I think minus 4z. Yes, so minus 4z minus 2. Then minus z times 6 will give me minus 6z minus 3. Then minus z times 4 give me minus 4z minus 4. Then minus z raised to the power minus 1 times 2z raised to the power minus 4 give me minus 2z raised to the power minus 5. Oh, this is tedious. Then you come to the next one. Okay, you go to the same procedure. So 2z minus 2 times 2 give me 4z minus 2 plus 2z times 4 give me 8z minus what 3 plus 6z minus 2 will give me 12z minus 4 plus 4z times 2 give me 8z minus 5 plus 2z times 2z minus 2 times 2z minus 4 will give me what? I think 4z minus 6. All right. Then we are left with the last one. That's z minus 3. So z minus 3 times 2 give me 2z minus 3. Okay. So plus z minus 3 times 4 give me 4z minus 4 plus um 6z minus 2 times z will give me 6z minus 7. Oh, let me see. Yeah, 6z, oh, 6z minus 2 times z minus 3 will give me 6z minus 5. Sorry. Very sorry. So 6z minus 5. Then 4z minus 3 times z minus 3 will give me 4z minus 6 plus z minus 3 times 2z minus 4 give me 2z minus 7. Yeah. Okay. Then once you are done, you have to add all of them. Okay. Yes. And you can try that in the process of addition you realize that the only term with nodes is 6. Okay, so your answer here will be 6 plus the next term. So you have 12z minus 1 plus minus 2z minus 1, and that will give you 10z minus 1 plus you have 18z minus 2 minus 4z minus 2 plus 4z minus 2. So that will give you the results of 18. Okay, like 18 plus 4 minus 4, that's 18. So 18z minus 2 plus the next one. You have 12z minus 3 minus 6z minus 3 plus 8z minus 3 plus 2z minus 3. So I think this and that would think it will give you 16 in a total. Yeah, so 16. So you get 16z minus 3. Okay, so that'll give you 16. And you can go and add the rest. Yes, so hopefully if we did everything right, then we should get 18z minus 4 and 12z minus 5. Right, yes. Then after we'll just find the inverse Z transform. So when you find the inverse Z transform of this, 6 will give you 6, 10 will give you 10, 18Z minus 2 will give you 18, then 16Z minus 3 will give you 16, then 18Z minus 4 will give you 18, and 12Z minus 5 will give you 12. Now someone asks, why is it that Z minus 1 and Z minus 2 are all having the same, how do you call it? Like the same kind of Z transform? Well, the Z transform is position independent, okay? So when I see 18Z minus 2, right, I know that 18Z minus 2 means that it is what? The second term. So that's why it is term 2, like when we start the index at 0. So that's why I put it here. I don't put it here. So the best procedure is that usually when you are doing this, so that you don't miss any power, once you finish multiplication and the addition, sort the term in decreasing powers of z in this case, okay, so that you cannot miss any term. Because, for example, in a scenario where you don't have any z minus 1 term, you have to put 0 here, right? But it's not shown directly in this equation. Okay, and that's what you have. That being said, the honest truth is there is another way to evaluate all of this, and I tried on my way of the video. I honestly don't like you going by this method, but if there is anything you have to beat in section A, then probably knowing this method might come in handy. So what you do is this: you can, instead of writing the whole convolution, you can take it step by step. Okay, now you realize that in convolution you're evaluating y of 0, y of 1, y of 2, y of 3, y of 4, and that's what we write as our answers. Okay, so the answers you see here, this 6, 10, 18, what our y of 0, so our y of 0 is 6, our y of 1 is 10, and so forth and so forth. Now here is it. If you want to do this without going through the whole tiresome multiplication, okay, now y of 0, right, the only way you can get y of 0 is when x of 0, h of 0. Make sure that the sum of these two numbers are both equal to what here. Okay, now y of 1, the only way you can get y of 1 is when you have either x of 0, h of 1, or you have x of 1, h of 0, right? Again, make sure that the sum, so this one, 0 plus 1 is 1, 0 plus 1 plus 0 is what? 1. Okay, then the only way you can get y of 3 is either when you have x of 0, h of 3, or you have x of 1, h of 2, or you have x of 2, h of 1, or you have x of 3, h of 0, right? So always make sure 0 plus 3 is 3, 1 plus 2 is 3, 2 plus 1 is 3, 3 plus 0 is 3. Always make sure of that. Okay, so now let's pick y of 0. So y of 0 is what? We say the only way you can get is what? H of 0, x of 0. Okay, so now you realize that when you label your terms, okay, so if we label our terms, so when we label our terms, this is what? X of 0, this is x of 1, this is x of 2, this is x of 3, this is x of 4, h of 0, h of 1, h of 2, h of 3. When we label our terms, okay, then our y of 0, which is equal to x of 0 times h of 0, becomes what? 2 times 3, which is 6, right? Remember, in our answers, the first answer was what? 6. Okay, so yes, we've gotten the first answer. Now the second one, we are supposed to do what? X of 0 times h of 1 plus x of 1 times h of 0. So x of 0 times h of 1, this is x of 0, right? So multiplied by h of 1. So you get what? 1 times minus 2, okay, plus x of 1 times h of 0. So this is x of 1, which is 4. H of 0 is what? 3, right? So you get 4 times 3, which is what? 12. So you realize that when you do 4 times 3, right, plus minus 1 times 2, you get an answer of 10. Okay, and now you come and watch the figure again. Our answer was what? 10, the second one. Okay, the third one was, we are supposed to do x of 0, h of 3, right? When we do x of 0, we have what? 2. H of 3 is what? H of 3 is 1. So 2 times 1 is 2, and that's what you see here, right? X of 1, h of 2. When we do x of 1, we have 4. H of 2 is what? 2, right? So 4 times 2 is 8. So that's what you see here. Then the next one, if we do x of 2 is 6, and h of 1 is what? -1, right? So 6 times -1 is -6. That's what you see here. And when we do the last one, x of 3, h of 0. So x of 3 is 4, h of 0 is what? 3, right? We get what? 12, right? So when you add all of this is 12 minus 6 plus 8 plus 2. Okay, so I think that's 16. Okay, so this will give me 16. 16, right? And when we check our third answer, is what? 16. Okay, now you can go ahead and do this, right? Now just be careful on how you do your expansion. Okay, and that's the only situation with this. Now to make sure that this video is not too long, I've not covered when you have negative sequence, like when you start from minus. You see that all these points we are starting at x of 0, right? And there is a little perk when you start from negative. Okay, so maybe the next one I'll touch on it. Thank you.